Okay, so we are going to learn some more details about Apache Spark. So what is Spark, right? So it's a distributed data processing engine, and it is mainly used for the fast unified analytics engine for big data and machine learning. Okay, so you need to understand few things here. So distributed data processing, okay, and a lightning fast unified analytics engine for big data and machine learning. Okay, as you can see, the AI, right? Artificial intelligence is uh, evolving at a high speed, right? If you are part of already working with artificial intelligence projects and all, it's every day something or other thing coming out, and you can see it's evolving at a fast speed, right? And yesterday, if you see Microsoft build, right, there were some announcements and everything is related to AI. Everyone is talking about AI. Okay, so AI is becoming a bread and butter of our software engineering, and everybody, whether you are a developer, whether you are an analyst, whether you are any whatever the role you are playing, you should be impacted by AI. Okay, now to take a step back, how AI works. Artificial intelligence can only work if you have a proper data with the quality, right? And then that can only be taken. You can take an advantage when you have a analytics engine where you can process the big data and machine learning at a scale, right? So it's not like, I got the data today and I will process, I'll take some time and then give the insight. It's not going to work. We have to process that at scale, right? So that is where Spark will come into picture. Is a distributed data process engine and a fast unified analytics engine for a big data and machine learning. Okay, so you need to understand what is machine learning. Okay, if you are new, just go back and see what is machine learning and how it's impacting day-to-day life of businesses. All right. Right. So what is distributed data processing? As for example, let's say you're getting a 100 GB of data, or some terabytes of data, right? And in a distributed manner, we will chunk the data into multiple chunks, right? We will split the data into multiple chunks and assign those to different computational resources. Okay, that's how the distribution works, right? For example, uh, I have a server and I have different nodes, right? So how do I distribute the work? It's like, think of you're a team lead, right? You got to do a bunch of work today, right? You have a team lead and you have a 10 members of team. So how do you do that bunch of work? You're not going to do alone. If you do alone, it's take months and years. So what do? You will distribute that work. Okay, team member one doing this one, team member two do this, do three do this, and accordingly you will distribute the work between the team, and then you at the end of the day the work getting done, and you will consolidate everything and you will send to your higher management, right? Similarly, when it comes to the big data also, when you're getting a 100 GB of data, or terabytes of data, it's going to be split into multiple chunks, and then accordingly you will work it, right? And one of the another benefit of Spark is it can handle up to petabytes of data with thousands of physical and virtual machines. Okay, if you take a look at how Google works, right? When you type something in Google, how it works, how are you getting the results, right? So there is a big, there are hundreds of thousands of workers and hundreds of thousands of nodes clusters being deployed into Google data center, and they do the work. When you type something, they do the work behind the scenes and gives you the results, right? Similarly, Yahoo has one of the biggest clusters they are deploying, which consists of thousands of physical and virtual machines. All right. So if you understand, these are the some of the general use cases, how uh, data, kind of a big data, getting processed every day, right? Have you ever imagined when you type in Google search, let's say you type something, how it process the data, how it process that request and gives you the result, right? So there is a huge amount of data getting processed behind the scenes, and within a fraction of seconds you're getting the results, right? And if the result is getting delayed, you will be pissed off, and you're no longer going to use, and that would impact Google's business, right? So when you type something, immediately the result is popping up. That means there is a very, very powerful big data engines are working behind the scenes to give you to process the data and give you the right information when you type something. Okay, so that's how the distributed processing works. Now, why Spark, right? So we were living, as I mentioned yesterday, in 2008 and before, right? Prior to that, we were living without Spark, right? Why now Spark? Because as as we are getting into the data age, and the data, enormous data getting generated through multiple sources, whether it could be social media, whether it could be devices, whether it could be sensors, everywhere the data is getting generated every day, and it's very important to process and get the insights out of that. Otherwise, the data goes in vain and nobody uses the data, and we cannot not able to leverage the data to predict something which is coming out, right? So the businesses are changing. Not nowadays, if you log into any e-commerce website or anything, you see there are number of recommended products come to you automatically. So how either Amazon or Flipkart, whoever it may be, how do they know that you are interested into these products, right? So there is a amount of data. When you purchase something, they track what you purchased, what you like, what you dislike, and then accordingly they process the data, and when you log in next times, you will get those product recommendations, right? Or if someone like you also bought similar products, and along with that they bought other products, they will also tell that people like you has bought these products, along with they also bought these products, right? So those kind of personalization, those kind of recommendations come to us. So how it's possible? It's only because of the data we get the process, and behind the scenes there are a lot of data getting processed, and you will get those recommendation and personalization to you, so that you will not break your head too much into spending your time into what product to be bought and what product not to bought, and which is good and not good, so that you will not spend so much time on that. Okay, so now why Spark? To understand any bit context, high speed data querying, analysis, transformations with large data sets, right? So we are living in a data age where the enormous number of data getting generated every day, every second, right? So it's very important to process the data and get the insights, right? And so Spark offers much less reading and writing, and from the disk multi-thread, right? So this is a kind of an architectural. So when we discuss a little bit about architecture, you will get to know how exactly Spark works. Okay, and you see the other point, easy to use APIs, right? So one of the biggest advantage of Spark is it supports number of APIs. Okay, and which is easy of deploying, readability and for maintenance. Anybody who can understand a little bit of engineering, they can easily work with Spark. Right, to again to answer your question, Sunita, you don't need to know any language, particular language, to work with Spark. Okay, there is a huge support of APIs available, so you just need to know which API to be used at the right time to work with Spark.
Okay.
And it's fast, and especially when you are doing an interactive queries, right? Suppose I wanted to, I got a I got a sales data today morning, right? So I wanted to do an interactive query and to understand what was my sales and where it is, who are my top customers, who are my, what are my top selling products. I wanted to know immediately. I don't want to wait for the data getting processed and then creating a table and then creating a dashboard and then I will take a look. I want fast. I want immediately. The moment the data got into my bucket, I want to query that immediately. So Spark also provides the interactive queries, right? And it supports multiple languages as we discussed yesterday. Is you can write Scala, Java, Python, SQL, any of those language you can use it. Okay, and to continue that, it's a speed, and it has a powerful caching mechanism to process the big data, and it has a powerful in-memory processing capabilities and ease of deployment, right? And it's real time, right? We are not waiting for some time to take to process the data. It's a real time. You can process within the milliseconds. And then polyglot, so is basically it supports multiple languages, and of course it's a scalable, right? as i mentioned as I mentioned the example, the number of workers you can scale in and scale out based on the requirement. Let's say you're processing 1 GB of data, so you don't need 100, you don't need 10 workers. But if you're processing 100 GBs of data, you might need more than 10 also. So it automatically, there is a configuration you can do. It can automatically scale in and scale out based on the workload. Okay. And now the ecosystem, I think we discussed yesterday. It it, uh, it provides, it is spread across the entire analytic space, whether it's a streaming, whether it's a structured, whether it's an unstructured, whether it's a machine learning, whether it's a complicated structure like a graph. Everything you can process with using Spark. And the core APIs being are available on in all four languages which we discussed. Okay, so what are the some of the common use cases, right? When to use Spark, right? So when you're doing a ETL, when you're doing a extra, I think yesterday also we touched upon this topic, the scenarios where Databricks come into picture. So the same scenarios like when you're doing a ETL or SQL batch jobs with large data sets and you wanted to process at scale, right? And you can that is one of the common use case to you to use Spark. And other one of the main important is streaming, right? Now you see, go back to any of nowadays, IPL is going a lot of streaming. You can see Geo Cinema and also G5. They are all providing a streaming apps to watch the IPL matches, right? If you take a step back and if you think how exactly the streaming happens, you will be bombarded, right? And there is a number of Spark systems been deployed to do the streaming. Otherwise, it's highly impossible, right? So if you go back, if you go back and see, go to their blogs and read how they're doing streaming real time um, matches, you will get to know the powerful of Spark. Okay, everybody using, there is a Spark engine behind that. Okay, so now and also the real time data getting from sensors, IoT, or any financial systems, you can process that as well. And also performing complex any analysis you want to do with the some from the data coming from the web activity and all, we can use it to process this Spark. And of course machine learning, right? One of the best suit to measure, do the machine learning tasks using the Spark. Okay, so now how exactly it works, as I mentioned, right? It's a distributed processing engine, right? So now if you see, there is a driver program and there is a cluster manager and there are number of workers, right? In this example, we have two workers, right? But there could be many. There is no limit on this number of workers. As I said, right? Yahoo data center is using one of the biggest clusters of thousands. I think it's more than 10,000 or some worker nodes. Similarly, Google, if you understand the Google data center to process the data, they are also using hundreds and thousands of worker nodes to process the data daily. Okay, so now to understand bit context here, so there is a driver program is available. Okay, so in the form of Spark context. Okay, so you need to initiate this driver program. So when you initiate the Spark context, okay, it automatically creates, based on the configuration and all, it creates a cluster manager and it creates the number of workers. Okay, and this is completely depending on your need, how many workers you want, how many what is the memory you want, you can customize and configure that. Okay. And yesterday when we are discussing about the cluster, we touched upon what is worker node and what is the memory and all, right? So we are going to deep dive in more detail today. So now what happens is, when you submit any work to when you create a Spark contest, and when you submit a work to be done, okay, immediately cluster manager takes that work, and he cluster manager has information about how many workers are there, how many are active, and how many are, working available to process that request. Okay, accordingly, he will this cluster manager will distribute the work amongst the worker nodes. For example, in this case, cluster manager knows that there are two workers under him right now, and whenever any work any task comes, he will split across these two workers, and then he will assign those tasks to these workers to do that. Okay, so now what happens underneath, there is a uh, you remember it's written in a Scala program, right? As we discussed about that. Okay, so those APIs, the tasks, what are the requests come to this, and it will convert into a Scala program tasks, and those tasks going to be assigned to the work nodes. And you can see every work node has an executor, caching, and task two, right? So what it that is, they will submit to this executor. So this executor will get the task and it will do the further processing and then gives the output back to cluster, right? Similarly, worker node 2 also does the same thing. And then cluster manager again takes that work back, and what are the output comes out of these two, and then again gives back to your calling program. Okay, so this is the typical distributed architecture. Okay, So now when you're working with hundreds of thousands of worker nodes, and there is a high chance that some of the worker nodes can fail also, right? Let's say I submitted a job task this one, and this worker node got failed. So what would happen? The work will be, and immediately customer manager knows that, okay, this guy had a failed. Okay, so the work whatever is assigned to him, he will assign to some other worker node. And after fixing this one, this is again available to work, and some new work comes again, it will be assigned to this guy. Okay, it's a typical distributed structure. Okay, and any that follows Spark also. Okay, now let's move on to some of the important concepts when we working with uh, uh, Azure Databricks. Okay, so what is workspace? Okay, so workspace is basically an environment for accessing all the Azure data assets. So what is data asset? Anything that you are required for your project. For example, you are doing a marketing analysis. So marketing analysis, what you need a notebook to write the logic, and you need some of the libraries, you need some of the uh, machine, some of the experiments you want to play, right? And all the related logical things that required to do the piece of work, that will become your workspace. Okay, so now let's see. So now you see, yesterday we discussed this one, right? Can you guys see my screen?
Yes,
Yes,
sir.
sir.
Yeah. So now you see there is a workspace. Okay, and we can create directly. We can work under the notebook. Okay, or we need to create a workspace. Okay, so workspace is uh, comes with two. One it can be shared, and the one can be users. So shared means the workspace when you're working in a real time, you will be working in a sharing environment, right? Where some of the tasks you might be doing, some of the tasks your teammate might be doing, and at the end of the day, you both have to be collaborated. Okay, so in that case, you will share the workspace with the others using this shared option. Okay, okay. So whoever configure using this workspace, they can also see what you are doing. Now some of them are user specific, which you don't want to share with you might be doing some POC on your own, or you might be doing some independent work that you don't want other to be shared. So those user specific tasks you can do it here. Okay, so automatically if you see the user specific, so I have logged in with my ID, so with my name, the users is available, and when I click, so this is what my workspace means. Okay, so the workspace means all the notebooks, libraries, folders, everything is bundled together to do the piece of work that is for the project, and that's how I manage everything into one workspace. I don't want to club it with other workspaces. Okay, so now you can, when you see, for example, let's say I want to create a folder for this is for marketing. Okay, similarly, I want to create another one folder for finance. Right? So I can manage myself that I can manage myself that when it comes I can only work with the marketing stuff related to marketing folder, and the other stuff, finance related stuff go into the finance. I don't want to combine and join with others, so that it looks very clumsy when you look into the, when you don't know which one is belong to where, right? Give a minute. So that's how I manage my work. Okay, is it clear so far?
Yeah, sir.
So you can see finance marketing got created. Underneath I can create my own, notebooks. I can keep my own stuff related to finance, related to market. I can keep it over here, so that it's a very easy to manage, right? And if you don't have this one, everything you clubbed into over here, and we don't know which one, without you, nobody knows which one is for what and what it does, and looks very clumsy, and that's not that's not the way we work in a real time. Okay, so
Oh,
that's the important of workspace. Now, next one is access control list. So access control list basically it attaches to your workspace, cluster and job table or experiment. So and specifies which user system processor granted access to the objects, right? So when in the same example, when you're working with um, uh, right, when you're working with multiple projects, like you, since finance is a little complicated, you don't want to give access to everybody, or marketing or something else, right? So those kind of access controls you can control for yourself as well as for your team members using those access control lists. Okay, so that very limited with the demo, but when you work with the real time, you can do those access controls as well. Okay, so notebook, I think we touched upon, is basically the web interface for creating and managing the workflows that can contain multiple commands, right? So if you see, uh, for example, finance, right? So I want to create a notebook. So this is basically a web interface, right? So this interface, you can write your logics, you can write multiple commands, right? That can be step by step. It can be executed as part of your logic, right? Let's say you want to when a file comes, you want to do the 10 steps, right? So how do you mention those 10 steps? You can execute these, create 10 commands and then run all, and one after another it will execute. Okay, so notebook is one of the key in Databricks. Without notebook, nothing exists. That because you need to, at the end of the day, you need to write your transformations and the logic to process that file, right? So if that is not there, there is no magic that or it automatically processes. You have to write the logic to do that. You may be selecting something, you may be doing some aggregations, you might be doing some groupings. All the stuff is going to be executed, and finally you can see the result, right? To do that, you need to write what are the different activities needs to be done. Okay, so library, so it's basically a package of code available, and by default Databricks provides, there are so many libraries. Okay, we will anyhow we were going to deep dive into that, but if you know any other third party, if you want to use any third party libraries, or you want to use any custom specific libraries that you want to work with, you can install those libraries, and then you can work with them as well. Okay, this is a very rare, happens in real time, maybe a 10 to 5 to 10% of projects, they might have a custom libraries to be used in the project. Otherwise Pretty much all the libraries that is required for day in day out are available in the Databricks. Okay, so the next one, Databricks file system. Okay, so it's basically a layer over a blob store. So it contains all the directories, files, everything that you wanted to use it as part of our workspace. Okay, so now if you see, if you go to data, right? See, right now nothing is there. Okay, so now you see, so DBFS target directory is file store and tables. Okay, so when I created logged in and created my own workspace, and automatically the Databricks file system got created for me, and you can see the path over here. Okay, so now any files you work with, any data sets you work with, and you upload the data, automatically all those files going to be landed over this target directory. Okay, and if you want to create any project specific folders within that, you can create that as well. You can create select and you can create those things here. Okay, but for now let's keep this, and you can see you can upload a file, and you can upload from S3. S3 is again it's a Amazon storage, right? AWS storage. And you can also from other stores you can get it as well. For example, you see there are so many connectors by default are available. Let's say you want to get some data from Kafka, Redis, MongoDB, any JDBC connectivities or Snowflake, Cassandra, anywhere that your data is there, you can bring it over here, and then you can work with those data and do the processing. Okay, so that's about um, Databricks files system. Now, what is database? I think this is a very fair question across the databases that we've been working in our real time, right? So it's basically a collection of objects such as tables, views, functions, organized and accessed in a managed way, right? So once the data comes, what you will do? You need to manage, you need to create your own database, right? So for that, it will give you create tables, you can create tables, you can create so on and so forth, right? And you can create a model, and then all those can be accessed from here. You can see data and you can create a databases. Okay, for example, you're working with the sales data, you can create a sales database, and all the related stuff related to sales you can keep it over here. And you're working with marketing finance data, and you can create multiple databases for marketing and finance, and all the data that you upload work with marketing finance can be tracked over here. Okay, so Metastore is basically an internal component for Databricks, and whenever you create a table, whenever you load a data set and all, it automatically captures some information about the data, right? So that's about the Metastore. Okay, uh, don't worry at this point. Okay, we will deep dive. Cluster, right? So again, cluster is basically you can set up computation resources and configuration on which you run notebooks, right? Now you see already, wait, whatever I do, it's already popping up there. No, I don't have any cluster. You need to create a cluster to access table, right? So no cluster is associated with. So anything and everything I do with the notebooks, I need a cluster to configure to manage my configurations and run my computations. Okay, so now you can see it over here. Right now I don't have any clusters. Okay, since we are using a community edition, so we don't have much options uh, to get the to create clusters. So now you see 0 workers and 1 driver, right? So, so that means we are using now if you go back, the right, so 0 workers and 1 driver. So driver is required. You can, without driver there is no Spark exists. So 1 driver given to us, but there are no worker nodes. Since it's a say community edition, so there are no worker nodes are available for us to do the larger data processing. Okay, so what that means is the community edition can only support to a certain extent of smaller data sets where you can run your Spark cluster without workers. Okay, and that can be managed with the 15.3 GB. But in your real time, this is not going to work. Right, you need some workers. Right, when you create a cluster, you will see different computations options with the different pricings that you need, and accordingly you will work with that. Okay, so let's see that what are the different types are available. Okay, so not here, sorry. So when you go to mm, and just to give an idea, these worker nodes are nothing but a virtual machines underneath. Microsoft takes those many virtual machines and it gives to you to do the processing. Okay, so now if you go back Azure Databricks here, let's create it now. Now you see the pricing tier here. Okay, so let's go back standard and okay, so here it's not coming. I think mm, yeah, so it's based on, see, cluster type, you need to process your thing, and accordingly you need to create those clusters. Okay, so that's the point. Okay, so accordingly the price and all the stuff going to be built. Okay, so now I can give my own way. Okay, set test. Okay, and then create cluster. See, you can use pay as you go model, or you can use committed use discounts, right? So all the stuff are available. So if your workflows and streaming jobs, it costs you 0.07 per dbu. What is dbu? Is a database unit to process a task, right? So if you see, before, when we're creating, you can see one dbu being given to us as as part of community, right? So similarly, if you are processing the delta live tables something, and if you're doing sql, it's going to be different cost, and serverless is different, and all other, right? So based on the need, you can choose the plan, and you can take those those many clusters. Right. So since it's a again community, so we don't have a much options. So the availability zone, everything automatically decided, right? Otherwise, you need to see what available zone you want these clusters to be processed, and you have an option, every all the options to choose the availability zones and everything. Right. So it takes a while. It within a minute or two, it can be available for us. All right. So Databricks runtime. So don't worry about this one. This is managed by completely by Databricks, right? They always release different runtimes for every often. Okay, the one which suits you the best, we can use that. And if you want any particular runtime to be, for example, in this case, if you can see, 12.2 LTS is what we are using, right? But if you want any specific runtime to be used, you can change those settings during the cluster. Okay. So workflows is what? Workflows is kind of a developing a pipelines, right? And giving a uh, giving completing the end-to-end pipeline of a logical units, right? So now let's say that I created a notebook, and there could be multiple notebooks, right? One notebook has to be called another notebook, and then it internally called something else, right? All those things I can configure using the workflow. You remember? You remember when we were creating ADF pipeline, right? How we were doing the different actions together, right? And similarly, the workflows will help you, but unfortunately we don't have in the community base, you cannot create a workflow. Okay, so no worries, don't worry about that. Okay, so again, on the same note, on the cluster, so based on the uses, they are standard. Okay, and they are now called no isolation shared access mode and high concurrent clusters, where you need high memory and storage and computation power clusters to process your data. And there is a single node cluster, right, where we don't have a workers. Right, the example what we got for community is a single node. There is no workers, nothing. It's all one man army. Okay. And some of the important stuff when you create a cluster, right? We cannot change the cluster mode. So let's say you got taken high concurrent cluster, then you cannot jump back to standard or anything else. That's not possible, right? If you want to change to standard or any other mode, you have to create another one. Okay, you cannot change the already created one. Okay, and since these resources are works as a pay as you go model. Okay, so what does it mean? You will pay only when you use to process data, unless Otherwise, you don't need those clusters, right? So there is a configurations available. You can set up after 120 minutes or something. They can automatically they will be terminated. Okay, and when you're working the high concurrency, they don't terminate. You have to do it manually if you want to terminate. Okay, so that's all about more about the Spark and also the about the Databricks workspace. Okay, now any questions?
Sir, what is the node means?
So node is basically the work.
Workspace, right?
It is a worker node.
Mhm.
Node is basically the one who does the actual work.
Okay.
Okay, so in this case, you can see worker node one, node two. You can have a number of nodes, right? And these nodes are nothing but when you choose a cluster, these nodes are nothing but a virtual machines,
Mhm.
right? So let's say you want a high concurrent cluster with a 10 nodes, right? So what would happen? 10 virtual machines going to Azure will provide you 10 virtual machines to deploy your to do this work. Okay, so the work can be distributed across 10 nodes and then you can complete that work.
Okay, sir.
Yeah. Anything else? Okay, I think we are good. So with yesterday and today, we completed the concepts. Now we are ready to work with Azure Databricks from tomorrow. Okay, and so be familiar with those concepts and be familiar with those things. Okay, and when we get into live, okay, so we'll be moving fast. Okay, so it's very important for you to understand those foundational building blocks. Okay, so do revisit and do some hands-on, not hands-on, do some reading. Okay, and from tomorrow we are going to discuss with we are going to work with the notebooks. Okay, and we're going to load some data, we're going to play with that, and we're writing some transformations, so on and so forth.
Yes.
All right. So
Yes.
if there are no questions, we can wind up for today and have a great day, and we'll resume tomorrow.
Okay, sir.
Chalo? All right, guys. See you tomorrow.
Okay, sure.